Welcome everyone to the 34th Annual Mayor's Environment Expo. My name is Charlene Fritz and I'll be running this session entitled Fire and Water. I'd like to thank the City of Calgary today for allowing us to present here and specifically to Nalini Mohan for all of her help preparing for this event. We'd like to thank you for participating in this Environment Expo. It's being recorded and you can access this recording with your link for 30 days. Attendees will not be able to share audio or video during this session. And if you would like to interact with the speaker or the presenter, the Q&A overlapping icon is how you will do that. The City of Calgary would like to thank all of the sponsors and supporters for this event, including transportation and workshop sponsors, as well as the venue support partners. Now I'd like to introduce Mayor Jyoti Gondek and her mayor's welcome to this expo.
Oki, Umbawastich, Dada Nastata, Tanshe, and hello. Greetings from Mohkinstsis, the place we now call Calgary, at the confluence of the Bow and Elbow Rivers. It is my privilege to welcome you all to the annual Mayor's Environment Expo. As we come together from around the city, I'd like to acknowledge that the Calgary area where the Bow and Elbow Rivers meet is a place of confluence, where the sharing of ideas and opportunities naturally come together. Indigenous peoples were the original caretakers of this land, beginning with the Blackfoot Confederacy. They were the first champions of environmental conservation, and this land is a home that we now all share. What gives me hope and drives my optimism is seeing the innovation and commitment to climate action from all of you, our students. You all have some incredible ideas to go forward with climate action, and I look forward to hearing them. We all have a part to play. The time for talking has long been over, and the time for action is right now. We at the city know that we are only one piece of this puzzle, and we can't do this alone. Collaboration is critical, and we are committed to working together to build a healthy and green city. Let's show the world that Calgary is a climate leader. I hope these sessions spark conversations and empower all of us to take greater action in protecting our environment. Thank you all for taking part this week and using your voice to amplify this important conversation and make vital change happen.
Thank you to Mayor Gondek for that message. I'd like to introduce our organization, which is the Ghost Watershed Alliance Society. And as a small watershed stewardship group, we work on a really important aspect of our environment, which is our water. We all use water every day for many different types of things. And in 2002, the Alberta government came up with the Water for Life strategy, recognizing that it needed to manage the water resources with partners. And partners such as ourselves, the watershed stewardship groups, we all work together to these three main goals, which is for safe, secure drinking water, healthy aquatic ecosystems, and reliable quality water supplies for a sustainable economy. Now, we work together on those three goals with partners, like I say, and the City of Calgary is a really important partner of ours. So how do we work towards those three goals? We do it in four main ways. We provide education and outreach like we're doing today. And I'm also hosting another session on Thursday around native trout. And we'll also be hosting an exhibitor's booth at City Hall for Tuesday and Wednesday of this expo. We also take and meet with kids on the river, students taking a look at various aspects of aquatic health. We conduct our own science and research, and we use that to provide advice and recommendations to the decision makers. And following that, we also recognize that there are areas that need repair, and so we work towards restoring ecological function. So that brings us to today's session, and the topic that I'd like to talk with you about today is fire and water. And the subtitle, How Wildfire Affects Calgary's Source Watersheds and Beyond. This is something we'll work through our entire session, but this image itself showing the clash of these two opposing forces, the fiery orange ball of the fire and the blue splash of water, suggests these opposing forces don't mix. What I'd like to suggest to you today is that there is actually a very strong connection. The other thing I would like you to do as you go through this session is hopefully I'd like to light a fire rather than to fill a pail, so to speak. And that is to spark your curiosity around these issues that you can take with you. So wildfire has definitely been on our minds very recently, especially in Alberta, with over 1 million hectares of forest touched by burning. So this image of the Pasqua fire near Fox Lake, Alberta, reminds us of the effects of fire on the land and in the air. And as these atmospheric currents have pushed this smoke south, several days in May, it was difficult to see and breathe in Calgary. Here is a wildfire status dashboard that you can access anytime to find out what's going on in the province. This was taken in early May, and of course it changes as different fires become under control, but it's a really interesting place if you are more interested in this topic. So I'd like to take you up now in an airplane. Before we go to the smoke in this fire, I just want to also mention to you that my thoughts do go to the people who have lost their homes and the areas that have been really affected by these wildfires, and to the brave firefighters who are still battling these blazes. And there are many, many kind volunteers also helping people to sort through and cope with the aftermath of those devastating fires in the north part of our province. So I just wanted to recognize that. So today, when we go back 3 years, so this is a fire that occurred in 2020, I'm going to have you sit with me in the airplane here and look down on the Ghost River Valley and at this plume of smoke coming from a wildfire, and it's obscuring a really important mountain, which we'll talk about in a minute. But I want to ask you, what is the connection between that fire and my drinking glass of water on my counter in the city of Calgary? How are those connected, and why does that matter? And so to do that, I'm going to take you on a little bit of a trip, if we can. We'll go way up in a satellite and look straight down on this part of our province. And you can see Calgary there, of course. It's the gray and outlined the footprint of Calgary. A little bit north is Airdrie, and a little bit west is Cochrane. And another familiar place is Banff. Probably many of you have traveled to Banff, and you know that it's in the mountains, in the Rocky Mountains, which are these white and gray bands here on the left-hand side of this image. So we know, of course, that mountains are high and our prairies are low, and water flows from high to low. So these mountains drain our water supply. You can see the rivers coming out of the mountains and flowing down towards Calgary. So the Bow River is the main river that connects Banff and Calgary, and it flows downstream. Ultimately, the Bow River meets the Oldman and joins to become the South Saskatchewan, and that water eventually makes its way all the way to the Hudson Bay. Now, the Bow River has many tributaries. You can see the Elbow River coming into Calgary down here, and the Ghost River is another tributary. So what I've outlined here for you is the Ghost River watershed, and a watershed really is just the area of land that collects and drains to a common point. So this outline is showing you the area of land that collects to the Ghost River, and the Ghost River empties into the Bow River. It's a tributary to the Bow River, and the place where that happens is right at the Ghost Reservoir. There's a hydroelectric plant there now. You can see all the fingers of water coming through that join into the Ghost River, making this watershed a really important area. The City of Calgary also recognizes that the watersheds that feed into its drinking water are very important. So the Bow River Source Watershed is the area of land that drains into the Bearspaw Water Treatment Plant, and the Elbow River Source Watershed drains into the Glenmore Water Treatment Plant. You can see the Ghost River Watershed as a rough red outline here, and it's just showing about 12% by area and about 8 to 10% by volume of the Bow River Source Watershed. So it's a really important place for the drinking water of Calgary. Now, Calgary very proactively in about 2019 started looking at source water protection. They put together a source water protection plan, and they call it a multi-barrier approach, which means they start at the source and they understand the drinking water treatment facilities are another important piece, and then they distribute that water to you as the customer. So in all of those steps, they do really important work. Now, when they looked at the source water protection, they asked, well, what actually could be some risks? They identified 2 key risks, and one of them was wildfire in the source watershed. So we returned to our airplane. So why would the City of Calgary identify this plume of smoke as a potential risk to this drinking water? And so here's your mission in this session. I would like you to decide, after we go through some of the facts and the science, did the 2020 wildfire in the Ghost River watershed alter Calgary's source water quality? And that's the question I'd like to pose to you today. To help you answer that, I'm going to go through three main sections, and I'm going to talk about what fire actually is. I'm going to talk about the land-water connection, and then give you some very specific facts about the Devil's Head wildfire that might help you. As we go through this presentation, you will see the, the yellow speech bubble, and that's when I'm going to ask you questions and pause to see if you can think about the answer. So our first image here is asking the question, what is fire? And I want you to place yourself inside of this image. Imagine you are standing very close to this fire, and you would obviously think about fire on a very human level at this point, and you would probably have emotions like fear. You'd want to be getting away from this fire. But if we take an objective science point of view, what actually is fire? It's a specific chemical reaction where different substances come together and react, and it's called combustion. So if we come back to being in our human frame of mind, what would you sense? If you were standing here, what do you see? What do you smell? What might you hear? What could you feel on your skin? What other observations do you have as you're standing here by that fire? So I'll give you a moment to think about that. I have lots that come to mind, and I'd like you to just to think. And so, of course, we would probably sense heat right away. We would feel the heat coming off this fire. There's a lot of light, and the color change. Even the flame color itself will change as this fire moves through the forest. There will be gas, which we think about probably as more as smoke, but it's really the lifting up of these gaseous substances, and that will create also the odor. So we're going to smell that smoke. And then we might notice that the ash is very different than those living trees. So the products of this chemical reaction are very different than what started out as the reactants. And so what's happening in a chemical reaction is just the rearranging of chemical bonds. And because of that rearranging, we get all of these clues, all of this evidence for a chemical reaction. The other way to look at fire is as a recipe. So a fire triangle shows you the three main components you need, the ingredients. You need fuel, oxygen, and heat. And we'll start with fuel and go through each of the three sides of our fire triangle. Without any one of these sides, you cannot have a fire. So let's start in the forest, and the wildfires we're talking about in the source water areas of Calgary would be mainly forest fires. You can get grass fires, but the really big fuel buildup are in our forests. So I'm standing here looking at these trees, and the trunks, the branches, the needles, the lichen draping from those branches, all of that is fuel. It can all burn. There's also things out of sight that are at my feet as I take this photo, things like fallen logs and grass and the shrubs in the understory. All of that becomes fuel. So what's actually inside the tree that will burn? Well, in general terms, they're organic carbons, just a sort of a fancy name for this group of chemicals, of substances that contain carbon, oxygen, and hydrogen. And the tree, through photosynthesis, creates simple sugars and then rearranges them into these really interesting and complex molecules like cellulose and lignin. And those are the things that give the structure to the tree. Now, those are the combustible materials. But we know, of course, there's other things inside of the tissue of that tree. There's water, so the water H2O, the molecule, and it is not combustible. But it does affect, if there's more water in the tissue of the tree, it's less likely to burn, and the reverse is also true. There are minerals and metals also in the tissue of the tree, like magnesium and carbon, and those are things that the roots pull from the soil and put into the tissues. They can also be absorbed from the upper parts of the tree as they breathe in through the atmosphere. Okay, so the second element, or the second side of our fire triangle, is oxygen. It comprises about 20% of the atmospheric gases, and it can actually also be a very limiting factor for combustion. So often there's not enough oxygen to keep the fire going, and then we get these incomplete combustible reactions. You can also think about the wind coming, and the wind supplies more oxygen. That's why when the firefighters talk about a wind coming as more of a risk to increase the intensity, it's because that is supplying more oxygen to the fire. And the third and final side that you absolutely need to have a fire is the heat or the ignition energy. And so here in this slide, you can see the natural cause, which is lightning. In this part of the world, that's the natural heat source. In other parts of the world, you could have a volcano that could start a fire. But of course, we would also have human-caused fires, so ignition sources from humans. And so there are many examples, but I've just put about 5 examples here on this slide. And you can see here that the government of Alberta has put out some information really trying to encourage people to reduce these human-caused wildfires. So this campfire, for example, if you were sitting here, this would be lovely, and it would be an amazing place to be on a summer night, for example. But you want to make sure that you soak it with water, stir it, and soak it before you left that site. Otherwise, embers could ignite another fire close by. On the top right-hand side of the slide, you'll see smoke coming from a fire started by an exploding target. Now, these are not allowed on public land, and they have caused fires in the Ghost watershed before. Other sources for human-caused wildfires, that ignition source could be a spark from a train track or a hot spot on an off-highway vehicle, or even a spark coming from a chainsaw. Depending on the conditions, what the fuel and the oxygen is in the area, any of those could be ignition sources for a fire. So recently, there's been fire bans on public lands and off-highway vehicle restrictions. Okay, we'll return to our forest. It's now burned, and I'm going to ask you a question. True or false? Do you think, are most wildfires in Alberta human-caused? True, they are mostly caused by humans, or false, it's mostly nature that causes wildfires in Alberta. So I want you to think about that. And you might have guessed what I've just described, that yes, it's true. Most wildfires in Alberta are human-caused. In fact, in 2020, when the Devil's Head wildfire occurred, Alberta Wildfire reported that 88% of all fires in Alberta that year were caused by humans. And when I looked at the stats in early May of this year, there were about 400 fires that had been started. 8 had been by lightning. About 200 were confirmed human-caused, and another 200 or so were still under investigation. So still overwhelmingly, it's human-caused fires. So it brings us to our land-water connection, and we're here in the Ghost again, and you can see the Ghost River Valley is covered in snow. This is about 6 months after the fire happened. And you can see what the land and the trees look like here. And I want to make this connection for you. But a quick safety moment, if you're ever hiking in these areas, please be careful. This inset photo here is showing the hollowed out center of the tree, even of these standing trees. So they're very likely to blow over or just topple over because they're quite unstable. That's our safety moment if you're hiking in those areas. So what is this land-water connection? This diagram does a really nice job of explaining some of the main things that'll happen in what we call the vulnerable first year. So these landscapes are the most at risk during that first year after the fire. So the fire has done really 2 things to our landscape here. You can see, of course, that water flows from high to low. Gravity still plays an effect here. So when it rains, that water will come to the land, but it's now no longer able to absorb into the ground as it usually can. There's minimal absorption because that surface layer of soil has been sort of baked, kind of like a hard-baked cookie. The other thing that has changed is that the vegetation underneath is no longer there, and that vegetation used to slow down the water and help it absorb as well. So with those 2 things changed, it's almost like a slip and slide. If you've ever done that in your backyard in the summer on a park hill, it's really fun to go fast down those really slippery slopes. Well, this landscape is now like a slip and slide. That ash layer will be mobilized, and that material will be transported downslope. As we know, water goes from high to low and it carries things with it. So that excess runoff and the sediment will end up downstream. So yes, landscapes affected by wildfire alter both the water quality and the water quantity in streams, creeks, and rivers. So we've returned to the Ghost, and we're looking at this baked soil and these blistered trees. And we know that when it rains, a lot of this material will be transported downstream. Okay, returning to our trees, we asked ourselves, well, what's the concern? If the city of Calgary decided that this was a key risk to its source water, there must be good reason. And so if we look at the three main groups of chemicals that they're concerned about, the organic carbons and hydrocarbons can be released during a wildfire. For example, polycyclic aromatic hydrocarbons, just a fancy name for a different structure of these hydrocarbons. Often incomplete combustion, there's also volatile gases that are released, but they can be toxic to human health, and they can also be toxic to aquatic life in the streams. That's one category of materials that they're concerned about. The second category are heavy metals, so things like lead and mercury, and those are also not good for human health or aquatic life. And then the third category of concern are nutrients, things like phosphorus, carbon, and nitrogen. And you might ask, well, nutrients, they don't sound so bad. Why is that a concern? Well, it's all about the concentration. It's about how much is released. So research done by the Southern Rockies Watershed Project in southern Alberta, a fire in near the Crow's Nest region. They studied the pre-fire stream bedding. You can see the gravels on the left are clear. The water's clear. You can see all those beautiful rocks. On the right-hand side, after the fire, there's a high nutrient input. So a lot of these nutrients from the wildfire enter the water, and you get a process called eutrophication, where essentially the algae grow like crazy because they have all this plant food, but they decay and decompose, and the bacteria that decompose them use up all the oxygen in the water and leaving very little available for fish and bugs. And so that makes the water quality go down. So nutrients in high concentrations can actually be a problem. Okay, I take you to another fire that happened in Alberta recently, and this is how we learn about what could potentially be a risk in Calgary. So you might remember, or you might not, the Waterton Lakes National Park fire called the Kenow Fire in 2017. You're looking at a portion of this, where this fire burned, of Cameron Creek. You can see this bear wandering across the creek, and on both sides, the scorched landscape. So when it rains, the materials will be mobilized or transported right into that creek. Now, if the bear returns in a couple of years, the greenery coming back in these areas will be fantastic habitat. But right now, it's pretty desolate. This creek empties out onto these rock beds, forming these falls. And so you're looking now here at Cameron Creek Falls. So I call this combustion soup. This is those materials transported off the land into the water. So the sediment does two things. It's physically clogging the water, but it's also carrying some chemicals with it too. So there's suspended and dissolved materials, and it's definitely not something that I would like to drink and just put straight into my cup. So I'm going to ask you to think about, of all the materials that I've discussed so far in this presentation, what do you think is in our combustion soup? What is churning around here in this pool at the bottom of Cameron Creek Falls? So just give you a minute or so just to think about what might actually be inside of this combustion soup. What's in this water that could be a concern? So we can think about the ash and the charcoal coming off of that land. The soil as well will come, creating this sediment. Sediment's kind of a big, broad term for all kinds of materials that are coming off the land, including organic carbons, those heavy metals we talked about, potentially lots of nutrients, and mineral content as well. So that all combines to be a problem if you're talking about drinking water. Imagine, though, if you actually lived in the water. And so our West cutthroat trout relies on clean, clear water to complete its life cycle. So they breathe through gills on the sides of their body, and if the water is clogged with sediment, it's really difficult to breathe. They also need clear gravels to lay their eggs when they spawn, and the alvin that emerge out of the eggs are very susceptible to being smothered if they don't have clear, clean water. Another creature that's at risk from that combustion soup is the stonefly nymph, and they are essentially like a steak dinner for those trout. These are the bugs that those trout feed on. They also rely on clean, clear water to complete their life cycle. So it's not a good news story if you get a lot of that material from a wildfire coming off the land into the water. All right, I'd like to talk now in our third section of this session about the Devil's Head wildfire in 2020. The technical term for it was CWF 156. That's a designation from Alberta Wildfire, and it really just talks about the fire region, and then the number relates to how many successive fires there has been since they started that designation system. So remember I talked about what a watershed was. It's an area of land that collects and drains to a common point. So you can see the mountains here on the west, and you can see the pour point or the outlet here at the Ghost Reservoir where the Ghost enters the Bow Rivers. And there are two yellow stars here that are both peaks of mountains that I'd like to take you to. The first one is Devil's Head Mountain. And just below the base of that was where the fire started in 2020. And it was an abandoned campfire. And it spread east to almost encircle Black Rock Mountain. So I'd like to take you there now and imagine that you can transport yourself with me. And we're looking here now on a ridge line, and we're looking straight west at Devil's Head Mountain. Now, from the city of Calgary, when you're driving, it looks like a thumb kind of poking up into the sky, and it's very distinct, and it tells you that you're looking at the Ghost River watershed. So the fire started just below over here, and you can see it came east, and you're looking at a southeast facing slope here that's all burnt. I'm taking you now to Black Rock Mountain, and I want you to imagine yourself here, the very top. I hope you can make out that tiny building at the top. It's a fire lookout, a historic one. It was built in 1928 by horses and pack mules, climbing up these steep trails with the materials like the wood and the nails and all the supplies needed for this lookout. And the purpose was to detect and then suppress and prevent these fires from happening in the sloped forests of the eastern slopes, knowing that it has a potential problem downstream for the prairie communities and their water supply. Now, in 1950, one of these trails was washed out and they could no longer bring supplies up. So they decommissioned it and built another one further north called the Mockingbird Lookout. Today, you can walk to both of those lookouts, and I would encourage you, if you ever get a chance, there's spectacular views from the very top. But this points to something in our history that we didn't quite understand in the early 1900s, that fire was a natural cycle, that the landscape actually needed low intensity, high frequency fires in order to renew and rejuvenate the landscape. Now, Indigenous people understood this, and they had a practice of burning on the landscape for millennia. And we're slowly starting to understand this now, that we need to make sure that fires happen in more controlled ways. But at that time, they wanted to prevent and suppress all fires. We know, of course, that we'd want the same if a fire was threatening our home, for example. So the quick facts about this fire, I put the fire triangle here. So we had a forest, of course, our fuel. We had really hot, dry conditions. The fire was ignited on September 4th by an abandoned campfire. They did an investigation. And it was actually brought under control in September of that year, but strong winds, remember I talked about that influx of oxygen, caused a flare-up on October 5th, and it burned intensively for the next 8 days. Luckily, wet and cold weather brought it under control on October 13th. It happened to be Thanksgiving weekend. A lot of the residents in the area were put on evacuation alert, and a lot of the livestock were actually evacuated in anticipation that things would get worse. Now, in the end, Alberta Forestry reports that about 2,100 hectares of forest actually burned, and this is similar to the area of Nose Hill Park in Calgary. So again, I'm going to just take you up on a satellite. We're going to look down on the mountains. You're familiar now with what Devil's Head Mountain and Black Rock Mountain look like from the ground. We're looking at them from the air, and you can see this orange footprint of the fire is really what burnt as a result of this wildfire. You can see the Ghost River flowing right through, and so the materials coming off the landscape will end up in the Ghost River, flowing ultimately to the Bow River and on into Calgary. So you can see on the left-hand side the forest, what it looked like before the fire went through, and I'm standing at the Ghost River. And this sort of similar vantage point after the fire, you can see sort of the scale of what had burned just below Black Rock Mountain. So I have a question for you now. how did humans make the fire triangle to start the Devil's Head fire? So we're thinking about fire triangle, we're thinking about the fuel, we're thinking about oxygen, and we're thinking about the heat or the ignition source that was needed to start this fire. Well, if we think about, first of all, the fuel involved, how we affected these forests in many ways by suppressing a lot of the natural low intensity fires, we've actually built up more fuel on the landscape. The other thing is with climate change, we know that our wildfire season is a lot longer due to the drier and hotter conditions. And that makes our fuel, there's less water in the tissues of the trees, so the fuel is more dry and more susceptible to combustion. And then, of course, we didn't blow wind on here, the Chinook winds that came October 5th, not necessarily related to anything humans have done, although some would argue that those are also a result of climate change, those more intense winds that time of year. That connection isn't entirely clear yet, but we do know, of course, that the ignition source, that the abandoned campfire, was what started this fire. So I take you to another section in the Ghost, and now we're standing on the Ghost River Valley again, but we're looking up to Black Rock on the right-hand side. And I want you to just notice a few things here about how nature affected the footprint of this wildfire. And so you can see this line up here, this ridge. This set of trees here is north-facing, and that's typically more moist. You can see that this burnt all in here, and of course was stopped as it bumped up against the rocks. What you're noticing here is a group of trees that weren't burned themselves, their branches and trunk, but the fire went underground and it burnt their roots, making them unstable, and they toppled over. So to recap, we ask you this question: how did nature break the fire triangle for the Devil's Head fire? So how were the natural features able to disrupt the ingredients needed for the fire? Well, you have moist fuels up here. You have no fuels here where the rock band is. And then the weather really came in and sort of saved the day with snowfall happening on Thanksgiving weekend. So that sort of, it smothers the fire, it reduces the amount of oxygen, it reduces the heat, and it put the fire out. So humans also helped to break the fire triangle in small ways. Certainly the weather changing was the big factor, but what you're seeing here on the trunks of these trees is fire retardant. And so ground crews and the helicopter both sprayed fire retardant in areas strategically to try to provide these fire breaks. They also had heavy equipment, and they bulldozed a big fire break. There's about 23 firefighters, one helicopter, and a whole sort of grouping of machinery that was used for that fire break. So we did our best, and Alberta Wildfire was actively fighting this fire for weeks. So this is almost towards the time when I'm going to ask you to see what you think the results were. But I want to summarize this talk by talking about drivers and responses. And this is a really nice schematic to summarize what I've been talking about. We have these wildfires in the headwaters and our source waters, and they cause impacts in our streams, potentially affecting our infrastructure like our water treatment plants. So you can see, for example, the fish here, the aquatic ecosystem can be affected by the things we've talked about, the nutrients, the heavy metals, eutrophication, for example. So what did the city do? Pardon me. What was the response? What was the actionable science that they did as a result of this fire? Well, they did a lot of testing. So we know that as a matter of course, the city tests the Ghost River at benchlands every month, and they did so all the way before the fire. When the fire happened, they really ramped up that testing. They increased the frequency, and they also increased the number of things that they were testing for, including those polycyclic aromatic hydrocarbons. So you can see the water test tubes here at the bottom photo. So they're taking some chemistry samples. You can also see the two government officials here from Alberta Forestry or Agriculture and Forestry and Rural Economic Development at the time, and they're taking samples. Can you guess what this red sludge is? And if you guessed yes, this is the fire retardant coming off the landscape and collecting in pools here. So they took samples, soil samples and water samples above the fire, at the fire, below the fire, and at Benchland. So in those 4 places, they took these and they took them back to the lab and they took a look at the results to see if they needed to adjust anything for water treatment. The other type of testing that was done was actually some testing by scientists, including those with the Ghost Watershed Alliance Society. And that's who you see here clustered in this beautiful landscape. The burn is right here. This is the Ghost River, and we've done aquatic invertebrate testing through cabin and stream testing. And I'd be happy to talk more about that at another time, but our results are still coming in, and we're still looking at the response of that aquatic invertebrate community to the wildfire in this area. Okay, it's your turn. We're returning to our airplane. We're looking down on the fire again. And I asked you, what is that connection between the fire and the water that I'm about to drink? What is your verdict? What do you think? And so I'm going to put it to you this way. The 2020 Ghost wildfire either improved or harmed or had little effect on Calgary's source water quality. So I'd like you to decide now, based on all of the evidence that I've just presented, the things you know that could happen to water quality, the different areas in the Ghost, and what happened specifically in that fire. Do you think that the Ghost wildfire improved, for answer A, or harmed, for answer B, or for C, had little effect on Calgary's source water quality? I want you to think about that right now. Drum roll, drum roll. I'm hearing a drum roll. Okay, so what did they find? When they did all of that testing, this is what they found. Most metals were not detected. Definitely the heavy metals that they were concerned about, the lead and the mercury, were not detected. Nutrients were found at elevated concentrations in the burn, but not more than the regular amounts at benchlands. In other words, they could definitely see that nutrients were at a higher concentration, but not enough to be concerning. They also found hydrocarbons, those things that we were concerned about for aquatic and human health. They were found, but in very, very low amounts, very low concentrations. And so their conclusion was, these are the city and the province's officials, the people that had done this testing, they came to this conclusion that CFW 156 actually is at low risk of affecting Calgary's source water. So the city of Calgary, luckily, did not have a negative effect from this fire. So if you guessed C or thought carefully and chose C, well done. So I'm going to ask this final question and then I'll wrap up the presentation. But why do you think that risk was low? We know that it was a relatively small fire. So for example, the Keno fire was 35,000 hectares. This Ghost fire was 2,100 hectares. It's also relatively far from the fire to the city. And that distance along the gravel riverbed would have allowed some materials to absorb into the channel, into the alluvial gravels. And the Ghost Reservoir itself, as the Ghost River hit the still water, a lot of that material would settle out into the Ghost Reservoir and never really ever make it to the city of Calgary. That concludes my presentation, and I hope that you found it interesting. You might have some questions, and I'd love to be in touch if you ever wanted to discuss this more or find out some more information about it. Again, Charlene Fritz, and that's my contact information there. I'd like to thank our supporters for making our work possible, including Alberta Eco Trust, Municipal District of Bighorn, the Bow River Basin Council, the City of Calgary, as I mentioned, Cochrane Environmental Action Committee, the TD Friends of Environment Foundation, Alberta Conservation Association, and the Land Stewardship Centre. And that concludes my presentation. Thank you.